Welcome to the Introduction to Basic Set Theory. In this module, we'll explore collections, intersections, and unions, which form the foundation of modern mathematics and logic. This is an important topic for building a base for math and logic. Here, a union B is shown with the mathematical symbol. Let's begin with the fundamental question: what exactly is a set? A set is defined as a collection of distinct objects. These objects are called elements or members of the set. For example, A is equal to the set containing the elements 1, 2, 3, and 4. Similarly, B is equal to the set containing the elements red, blue, and green. And C is equal to the set containing the elements A, E, I, O, and U. To work with sets effectively, we need to understand some basic notations. The symbol, which looks like an element, indicates that an element belongs to a set. For example, 3 is an element of the set containing 1, 2, 3, and 4. The symbol, which looks like an element with a slash through it, indicates that an element does not belong to a set. For example, 5 is not an element of the set containing 1, 2, 3, and 4. The empty set symbol represents a set that contains no elements and is denoted by open and close curly braces. The notation absolute value of A represents the cardinality of a set, which is the number of elements in the set. For example, the cardinality of the set containing 1, 2, and 3 is 3. Sets can be classified into different types based on their properties. A finite set is a set that has a limited number of elements. For example, the set containing 1, 2, 3, 4, and 5 is a finite set. An infinite set is a set that has an unlimited number of elements. For example, the set of natural numbers denoted by the symbol n is an infinite set and includes 1, 2, 3, and so on, extending indefinitely. A universal set is a set that contains all the elements under consideration in a particular context. For example, if we are discussing students in a school, the universal set denoted by U might be the set of all students in that school. The union of sets is an operation that combines all the elements from both sets into a single set. The union of set A and set B, denoted as a union B, includes all the elements that are in A or in B or in both. For example, if A is equal to the set containing 1, 2, and 3, and B is equal to the set containing 3, 4, and 5, then a union B is equal to the set containing 1, 2, 3, 4, and 5. The intersection of sets is an operation that identifies the elements that are common to both sets. The intersection of set A and set B, denoted as a intersection B, includes only the elements that are present in both A and B. For example, if A is equal to the set containing 1, 2, and 3, and B is equal to the set containing 3, 4, and 5, then A intersection B is equal to the set containing just 3. The difference between two sets is an operation that finds the elements that are in the first set, but not in the second set. The difference between set A and set B, denoted as a minus B, includes only the elements that are in A but not in B. For example, if A is equal to the set containing 1, 2, and 3, and B is equal to the set containing 3, 4, and 5, then a minus B is equal to the set containing 1 and 2. Venn diagrams provide a visual representation of set relationships. They use overlapping circles to illustrate the relationships between sets, such as the intersection and union of sets. In this diagram, circle A represents set A, circle B represents set B, and the overlapping region represents A intersection B, which contains the elements common to both A and B. Sets follow certain properties that govern how they behave under different operations. The commutative property states that the order in which sets are combined using union or intersection does not affect the result. That is, a union B is equal to B union A, and A intersection B is equal to B intersection A. The associative property states that when performing multiple unions or intersections, the grouping of sets does not affect the result. The distributive property describes how union and intersection interact with each other. A union B intersection C is equal to a union B intersection A union C, and A intersection B union C is equal to A intersection B union A intersection C. The identity property involves the empty set and the universal set. A union the empty set is equal to A. An A intersection the universal set is equal to A. Set theory has numerous applications in various fields. In computer science, it is used in database queries, algorithms, and data structures. In logic and reasoning, it is used in mathematical proofs and formal logic systems. In probability, it is used to define sample spaces, events, and statistical analysis. These are just a few examples of how set theory is applied in different areas of study and industry. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.